On behalf of Engineering Council of India, Indian Concrete Institution, Association of Consulting Engineers, Firefighting Chapter, I extend warm welcome to our all friends, dignitaries and other colleagues. In commemoration of birthday of Bharat Ratna Mokshagun Visvesvaraya, the Engineers Day is celebrated across the country. We too have got the privilege of celebrating Engineers Day, having the honoring the legendary Visvesvaraya Garu. Born on 15th September 1861 in a remote village, Mudavalli, in Kolar district of Karnataka. Let's have a brief introduction of this. His real engineering genius in preparation of schemes for flood protection works and underground drainage, and also modern system of sewage for Hyderabad city in 1909. Served in different parts of country in various advisory capacities, his brilliance in engineering benefited all the parts of the country and endeared him to people of all parts. His immense services in the field of civil engineering and national planning will be an inspiration to generation of engineers. So on this occasion, I request Sri S. Surinarayan Garu, Chairman, to preside over the function. I cordially invite our guest of honor, Sri P.S. Rao Garu, Gayatri Vidya Parishad President, to kindly approach the dais.
Now we'll garland Visvesvaraya's photo. Normally 15th September is Mokshagundam Visvesvaraya's birthday, which is celebrated throughout India. He was awarded Bharat Ratna. He was the famous engineer. So we celebrate as Engineers Day. So, but 11th has fallen on Sunday. So we are just celebrating 3-4 days ahead, which happens in most of the engineering societies all along India. So let us start with lighting of the lamp and garlanding Visvesvaraya. Thank you. The presentation by Radhakrishna Garu on offshore berth construction. But before that, I request Engineer Vana Devi Prasad Garu to introduce with the biodata of Professor P.S. Rao Garu and Engineer Garpati Radhakrishna Garu.
It's a great privilege for me to introduce our today's speaker, Garpati Radhakrishna Garu, son of G. Satyanarayana Garu. Date of birth, 1st January 1963. Qualifications, Bachelor of Engineering Mechanical from Andhra University, completed in the year 1985 with the distinction in first class. Education profile: studied in Sainik School, Korekonda and Vijayan District with merit scholarship of Government of India. Secured a gold medal from Government of India for having been adjudged the best cadet in All India Sainik School meet in Pune. And also represented Andhra Pradesh in Republic Day Parade. Experience: managed teams of highly professional people in executing various types of civil and mechanical engineering works, concentrating in specialized marine and bridges, review drawings, and ensure work done according to the same. Monitoring work to be executed on time and quality, technical discussions with clients and their technical persons at tender stage during implementation and suggesting alternative methods of cost savings, etc. Business profiles: started implementing site grading, land development, road making, heavy precision machinery foundations from 1985 onwards as a partner of firm Mrs. Radhakrishna Constructions. From the year 1994, retired from the state partnership firm and started doing business as sole proprietor under the name of style RK Engineers and Contractors. The company later got incorporated under the Companies Act with effect from 1st April 2005 under the name of style of RKEC Projects Private Limited, and to take over to carry on the existing proprietary business of RK Engineers and Contractors. The company is converted into public limited on 10th November 2016 as RKEC Projects Limited. Having strong organization set up with dedicated personnel with excellent experience in the concerned fields such as business strategy, financial management, project implementation, progress monitoring, etc. RKEC Projects Limited is a construction company for 34 years old, specialized in the business of infrastructure projects consisting of construction of buildings, highways, marine works and bridges. During the last 3 decades, the company has undertaken and successfully completed diversified construction projects across India. The company has so far completed 92 projects worth around over 1,70,000 lakhs crores and is currently handling 9 property projects worth 875 crores. The company achieved a revenue turnover of 247 crores during financial year 2018-19. The company's strong engineering capabilities, backed by an experienced execution team, has enabled the company to achieve its growth plans. RKEC Projects Limited is ranked among the top 10 companies for designing and executing marine structures and bridges in the country. The company has so far been executing offshore construction projects since 1985 and offshore infrastructure projects since 1994. The company is a proper special class registered contractor with MES-DGNP, DRDO and various state governments, which gives unlimited tendering capability. RKEC Projects Limited has attained good reputation among the clients because of the track record, experienced team members, and the proven strength of on-time delivery and quality norms across the spectrum of services. The company has entered into projects for diverse range of clients such as NHAI, PWD, DGNP, Indian Railways, ports like COPT, JNPT, MBPT, Adani and Nisar to also government departments such as NWCDMC and PUVBNL, among others. So that's all about our guest. I request the speaker to proceed the lecture.
A very good evening to all of you. Respected Professor P.S. Rao Garu, the tycoon of marine foundations in India and godfather of the marine foundations from IIT Chennai. Professor VVS Prasad Garu, Professor Head of AU Mechanical and Marine Department. Ms. Devi Prasad Garu, Suryanarayan Garu, Sudhir Ponnada, and Mr. Venu Gottipati from the Indian Concrete Institute Management Committee, respected Executive Committee members, ACA Managing Committee members, gentlemen and engineers. Today we are here to talk on the Engineers Day, and Mr. Suryanarayan Garu and Dr. Venu Garu has requested me to give a presentation on marine structures. I don't know whether I will be able to give a marine structures before a renowned person sitting over here, Professor P.S. Rao Garu, who is the founder of marine engineering in India with all the designs and all. But I will try my level best to give the best whatever I can do it, and the engineers can understand from whatever the experience that we have and they should gain. The young engineers, I would like to just give you a small tips. When you finish your engineering or even any degree, whatever is there, and when you just start entering into a career or you want to select a career, first thing is you have to identify your needs. Then the communication of the need, whatever is there. Then the implementation. These three are very much important in accomplishing your goals. See, you have seen a civil engineer, mostly maybe civil engineer or engineer, he has lived for 100 years, and the stressfulness of engineers is the highest among all the other disciplines available to us. But still, we find our Moshkondam living for more than 100 years, and it's not a joke. So, if you involve yourself within the engineering line, move forward, you will have a better life, better health, and better understanding and better living. So this is an example that what we have. And the other example what we have is our Mr. P.S. Rao Garu, who is sitting over here. Even today, lot of IIT students, his students will still consult him for any suggestions or any decisions that is required in the engineering practices. So I take up on now with my presentation on marine structures. So I will not take, maybe I think they have given me about 45 minutes time. So I have got 3 presentations which I will quickly run through, and you can have your question and answers once that is over. The first one what we would like to give you is the different types of marine works, or different types of marine works, marine constructions that we handle in this country with whatever equipment that we have, with whatever specialization we have, is being given over here. See, the first and foremost thing what we are having in the marine structures is pile foundation. Then the methods of pile foundation. In that, then in pile foundation itself, there are 3 types of pile foundation, which is by tripod method, the jack-up method, and gantry method. There are other driven cast in situ piles, auger piles, rock piling, and then these foundations being done underground, we don't know what is happened. So we have got to test whether this pile foundation, whatever has been given for the load, it is taking the load or not. these piles are to be tested. In early days, we used to test maybe up to 2000, 2005, we used to test piles only up to 500 tons, but today we are testing piles up to 4000 to 5000 tons on each pile. So the technology has also much gone ahead. There are scientific methods of doing this one also. So I'll just quickly go through the pile foundations, whatever are there, the testing, whatever has been done, and then I'll explain you two projects which are very critical and how we had executed those two projects. We'll give you a presentation on that. The first one is based on installation method is cast in situ, bored cast in situ, driven cast in situ piles, then driven precast piles, bored precast piles. Next. Based on the materials, we have concrete piles, timber piles, steel piles. Of course, now the timber piles have gone out of this one because of environmental issues and all. Mostly left out are concrete piles and steel piles. Next. Bored cast in situ piles. These are the activities that are generally done in the bored cast in situ piles. First is, being a marine structure, we have got to do the piles in the sea. So a liner with MS plate is required, which is done in the first stage. The driving of liner is done up to the hard layer. Then the boring is done with different methods, which we will explain you to that. To retain the soil around the pile foundation, whatever we is doing, we use a bentonite solution which holds the soil not to collapse. Then the reinforcement close lowering, Treme concreting, load testing. These are the activities that we generally take it up in these things. The first one, what you see is, I have told you the liner, this is MS sheet liner which is driven up to the hard strata. Then you keep boring, still drive the liner till the bottom. Then the liner is taken up to the hard layer wherever it is at a refusal point, and from there on you still to the go for the boring till the foundation level, whatever has been described as per the design. Once this is over, you lower the reinforcement cage into this. Next, we lower a Treme pipe because this is all filled up with water, so you can't mix the concrete with water. Hence, you will be putting a Treme pipe till bottom of the pile, and then the concrete is poured. As the concrete is poured, the pipe is lifted up, and it is seen that the pipe never comes out of the concrete while this is done, so that the concrete and water does not mix up. So this completes the concreting. This is the complete set of piling. Next. Methods of boring. There are different types of methods of boring depending upon the soil conditions. The engineer has to select which type of boring is required. One is baler and chisel. So I'll just explain in the photographs so that you'll be able to understand easily. There is a direct mud circulation method and reverse mud circulation method. Direct mud circulation method is you start pouring the liquid from the top, you just pour it. Reverse mud circulation is you take the liquid to the bottom of the pile and then lift up the mud, whatever is there. Then there are rotary drilling, which is the latest technology that is being used up now. So these are called the baler, actually, which lifts the soil, whatever is there in the pile. Next. These are the flap plates that we have at the baler. So when you push the soil from the top, these flap plates lift up, and whatever the soil is there, it gets collected. The flap plates closes, and then the material comes up through this. Next. This is the chisel. Wherever the soil is there, if it is hard enough, it has to be chiseled and then make up loose so that the soil can be bailed out. And then the concreting, whatever is there, is to be poured after the things are completed. Next. Different methodologies of piling. As I said, there are different types depending on the site conditions, locations. We have to use different types of method of piling. One is using tripod method. Second is a jack-up platform. Third is a gantry platform. This is the tripod which stands on three legs. That's why it is called a tripod. The pile will be at the center. You keep boring, chiseling and doing it up wherever you can do filling and then do the job. Next. This is the same type. Next. Jack-up barge. This is a jack-up barge, just like it has got four legs. Suppose if you want to go and do the piling somewhere in the middle of the sea, it can go up to 45 to 50 meters depth base, and you can arrange a stable platform over there which we can do the piling. Next. So this is with a hydraulic rig on the jack-up barge which has been established and the piling is being done. This is a jack-up barge which stands, and even the normal rigs can be put up on the jack-up barge and it can be done. The next is the gantry method. You erect a temporary piles over here, you erect a gantry, and over the gantry you erect the booms. Along with the booms you start driving the piles. So this is how the pile is done. A platform is completely made up. Then the supports or the guide pins are arranged along this. The pile is driven, and then it keeps moving forward on the wheels, which I will show you in the next slides. This is how the baler and chisel boring happens. Yeah, liner being pitched. You can see the liner being pitched into the ground level, and then you keep the boring. The reinforcement case which is being lowered. Then it is important to see that the bottom of the pile does not have any soil content or any waste pieces, and also we flush the pile once the boring is completed. We flush with either a fresh bentonite or with fresh water. If the liner is up to the bottom and there is no collapse of the soil, we generally use a compressor and just do it with fresh water, which is done here like this. But in normal DMC piling and all, we do it with a fresh bentonite and check the properties that whatever the flow out is coming up, it should have 1.1 density. It will be checked, and accordingly the pile will be passed. So concreting of pile generally is a concrete pump from wherein you pump it up and then do the concreting, as I explained earlier. These are the different temporary bridges that would be appointed, that will be built to construct the main structure at some locations where you don't have the protection of the sea. Generally all the ports are covered with breakwaters to see that you don't have that much of swell. But where you don't have an opportunity of that, you have got to build up temporary bridges like this and then move forward. Next. This is the piling what we generally do in the seas and all. Next. These are the wheels which we use it for movement of the gantries from one pile location to the other pile location when we shift. These are the wheels that we put it up, and these gantries move on around 6 wheels completely to the front. So this is the shifting arrangement for the wheels. Once the gantry's first location of the piles is completed, the gantry is to be shifted to the next. So this is the shifting arrangement that we use for the gantries. So this is how work is done in an open sea, wherein you have a side one with this one is with a temporary one, and then the other one is with a main work. Next. This is how the work moves forward in the sea, where there is no protection of the sea waters with respect to the breakwaters and all. These unprotected areas, we have to be very careful in such type of works. So how we keep carrying it out, we will just show you in next picture. How we have gone forward, I will just show you in next 2-3 slides. So this is how the piles are done over here. This is how we make a platform at the bottom, and this is where the people keep moving forward to the front, take the material and all other things through this platform, walkway, whatever is there, this will be carried out and moved forward. Next. This is how it moves forward. And sometimes we have got to do the piling not only with baler method, but we have got to do with DMC method also at some locations. So we put up the tanks over here only and then keep moving forward. This is how the platform. Next. Yeah, these are the gantries that are being erected at some of the locations of our sites, which I will just show you in one of the sites what we have done. Next. Similar. After these hydraulic machines that have come up, due to the scarcity of labor, now we have started designing the gantries also with to support these hydraulic machines, which weighs around 90 to 100 tons. So we have started designing and we have started doing this also so that the work can be progressed faster. This is a reverse mud circulation machine, wherein generally we use these machines for diaphragm walls, wherein if the land is to be protected from erosion to the sea and all, we have got to do the diaphragm walls, and the diaphragm walls are done with these rigs. We used to do earlier with these rigs. Now the latest hydraulic machines also have come up with grabs and all. We are doing it. But if you are to go into the rock, these machines are the best even today, proven to be the best rigs whatever available, though the work is slow. Driven cast in situ piles, these are often not used much now. Auger piling also, it is used only at shallow depth pile wherever it is required. Next. So these are the methods, the continuous flight auger this is called, and it takes the soil completely from bottom to top at a time. Next. Rock piling. Now, as I said, we are going with testing of piles to 4,000 tons like that. So the piles are to be taken into a very hard rock and even up to 10 to 15 meters depth in the rock has to be bored. So now a special type of equipment that has come up over recently, and these equipment can drill into the rock up to 10 meters, 20 meters, and even dias up to 2.5 meters we are able to do with this type of equipment over here, which costs nothing less than 20 crores. So this is the machine what we use it over there, and this is the chisel what is being used for that. So this is how the total setup is done for this machine, and then it keeps boring up. These are the tools that we have. These are all completely fitted with rock bullets, diamond bits specifically, and then it can keep boring into the rock. These are the different types, different dias. So there are other driven precast RCC piles also. Earlier they used to do, but now it has almost reduced. Not even 1% of the works in India are being used with these precast systems. These are driven precast piles, driven cast to hammer and all, which used to be done earlier. Now I think it has almost come to an end. So this is a sheet piling work wherein a vibro hammer is used to drive the sheet piles to protect the land without erosion into the sea, and maybe even doing some of the works wherein water has to be stopped. So these sheet piles are used, and a vibro hammer is used to do such type of things. These are the more equipment that we generally use it in marine works over here now. These are driving of sheet piles to this. In some of the locations we also use these sheet piles directly to build the jetty. But in some of the locations we use it only for retaining the soil and other things. Next. These are sheet piles that we have done in one of the projects in our projects at Kakinada and Visakhapatnam. Next. Then load testing of piles. This is very interesting. See, this is a dynamic load test which has come recently. Of course, though it has not been approved by IS standards in India, but British standards approve this system, and we are going ahead with this dynamic load test, which we can just finish it up very fast without much cost. The cost also is very less. This is how the things are observed while dynamic load test is there. Next. Then these are the piles which we do for this is a pile which we have done for about 2,000 tons load test. How we arrange the pile is located at the center over here. We have 4 anchor piles which are driven all around these piles. These anchor piles are fixed to these ends over here, and the load is taken from these anchors, which gives you up to around 2,000 tons over here. These are the jacks that are arranged for load testing to give the load. This is the initial arrangement for a shorter range of test piles. Next, this is one more system wherein without having such a huge beams and all, a shell circular, this one is made as per this, and anchors are connected, and this test can be done up to around 2,000 to 3,000 tons with this system. This is another load test which we have done it for about 4,000 tons. Next. Yeah, this is the final arrangement. After completing of all the arrangements, this is the test which has been done for 4,000 tons. Next. Yeah, this is the jack which has been used for that 4,000 tons. Next. Yeah, this is the methods that generally what we use for our rigs and for our marine works, mostly for all the marine works. And now I'll just give you a presentation on two projects. One is a marine project and another one is a seawater intake project, which we have done on our own. This project has been done for Cochin Port Trust, costing about 217 crores, and it is done on an EPC project. Our engineers have designed this project on our own and executed. This consists of previous slide. This is an oil berth actually, which consists of breasting dolphins, 4 numbers. These are mooring dolphins, and this is a central platform, and this is the approach trestle, and there is a pump house. See, in oil berths, the safety is more important. So in order to look at the safety, a fire pump house is built up so that the water, if it is required, if there is any fire or anything, it can be used for that, and hence the fire pump house is there. And there is a barge berth which has been constructed over here. It also has a sea protection valve over here, which has been done throughout for about 1.5 kilometers. Then this area has been completely filled up by us. Land has been acquired, land has been filled up and brought up, and this construction has been done. I'll just show you how this project was envisaged and gone through. Purpose of this project is Cochin Port is situated in close proximity of the international shipping routes, about 11 nautical miles from the Gulf, Singapore or Far East route, and 76 nautical miles from the Suez, Singapore or Far East route. This project, which is expected to serve as international bunkering terminal at Cochin Port Trust, presents an attractive economic opportunity for India. The sole aim of undertaking such activities is to have the benefit of a deep water marine facility near Putwaipin. Yeah, this is the entire view of the jetty, a 1-minute video of the entire view of the jetty which has been done. There is nothing, all this is completely empty when we were in the site. So it has been filled up, a seawall has been done, filled up, and then the work has been executed. That is the entire project, what we have executed. I will just show you how we have gone through each method of doing. As I explained you earlier, the methods of execution of the project, will just show you how the process of piling goes on at the site. This is the piling works, you can just see how they keep moving. The first is we manufacture these shells with an MS plate over there at the site. This has been pitched over here, and then the liner is driven with the help of a monkey. It keeps on driving it up. Then the baler system or baler and chisel is used to see that the soil that is there, it comes out. You can see the baler, this material that comes out through this out, and then this is put it up. It keeps on going down. Now this is the reinforcement case that we lower once the founding level is reached. Then after that, the reinforcement case you can't do if it is 40 meters depth, you cannot do it at a time, so you have to weld it. Then this is the Treme pipe that is lowered till the bottom of the foundation, and this is the flushing that we do over here. And then the concrete. This is the general system that it is followed in any marine works. Then once that piling is over, you have got to, just wait, come back. you will have the piles to be chipped to the cutoff level, because there may be some particles which are mixed up with the concrete, so the latent concrete has to be chipped off, and it is to be taken up. Yeah, this is how you chip off the piles. Then the civil works. Civil works, either it will be a cast in situ or a precast item. We generally follow the precast item. So the precast pile caps are put up over here, this side and the other side. These are the precast pile caps that we put it over here. Then we connect the beams with the cross beams. These are the precast beams that we do it over there, and these are erected with the help of a crane. This is how they are lifted and placed at the position. And then the top portion of the concrete is filled up, and the rest is just like any other civil work over here. Only thing is the workers work at the waterfront, where they should be careful with the safety and other issues. So the overall project layout is this, sir. This is what I have shown you earlier. This is the layout of jetty and all those things, wherein we constructed all other issues and all. This is the layout, general layout. Next. This is the requirement of the client with 4 mooring dolphins, 4 breasting dolphins, 1 center platform and approach trestle with a pump house. And then the barge berth for oil tankers and all. Initially, to start with such works, we start with a gantry fabrication. The drawing will get approved, and then accordingly the gantry fabrication is done. Then the construction methodology, whatever we have, the components I have already told you earlier. So the approach trestle we just started from over here. As I said, all of this area has to be filled up, so we had to drive all these as a temporary piles, and the permanent work started from somewhere over here, about 70 meters from the land, and then the approach trestle moved over from here to further. This is the approach trestle up to the end. This is a mooring at the breasting dolphin. We had launched 1 jacob barge as well as 1 gantry. We have used both systems of gantry as well as jacob barge depending on the work time and place. So these are precast items. Once the piles are over, pile caps are chipped. These are precast beams that have been put. Slabs, precast slabs are also put, and then slab has been done. This is how the mooring dolphin it looks once it is completed. And then piling for breasting dolphins. These are the breasting dolphin where we do all the works of civil work. Reinforcement is going on for this. This is the approach completed. You have both sides breasting dolphins over here. Next, this is also one of the breasting dolphin completed. This is a status of project at 1 stage. This is a pump house being constructed over here, as I told you, for firefighting system and all. This is a pump house. It requires about 3 to 4 floors. The control room, everything remains over here only. Yeah, barge berth is similar system only. It is a very small one. Next, 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 next. Yeah, these are other civil works required for the work, like the pumping station, pigging points and all other things. These are the civil works being done for that. Next. Similarly, this is the completed one. Next. So reclamation and shore protection works, as I told you, we have built up land for about more than 20 acres over there with a shore protection of this. If you see, this is with the stones that we build a shore protection over here for about 1 kilometer length, and all this area has been filled up. Next. 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 Yeah, this is the final completion, of course, which you have seen. Next. 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 This is a firefighting system. If any fire is there, a layer of fire is between the ship. Ship generally stays over here and the berth is over here. So it is defaced between both the things. When if any fire occurs, between the ship and the jetty. Yeah, firefighting you can just see. Yeah, this is how it covers even the ship also. If any problem is there, it covers for the ship also as well as the jetty. Everything is barricaded once any fire accident or anything occurs. And this whole design, everything, execution and design has been done by us completely, including mechanical and electrical works also, sir. Hold, up on. So this is the one of the works that I have shown you over here, which is a marine work. So if I want me to continue with the other project, I will continue. But otherwise, if anybody has any doubts on this structure, before you forget what has been exercised over here, because the other project is a different marine structure which I will be showing. So anybody having any doubts, questions and answers, may please move on. Or if you want me to move on for further next project, I'll move on.
What kind of firefighting you require there? Where you require firefighting in such structures?
Yeah.
Where you get the fire? Firefighting.
Yeah, firefighting equipment, we have done the complete firefighting system. Sir, if a fire occurs,
Where fire occurs? How it occurs?
generally accident, you don't know the fire accident, how it happens.
General accident.
Yeah, it is a general accident only.
Not due to the equipment.
No. It is anything, any accident that occurs, any misuse of anything or misuse of anything, the system is in place.
What type of ground improvement technique was taken?
Sir, I couldn't get it.
What type of ground improvement techniques have been taken in reclaiming the land? Because a lot of civil engineering structures come onto that land.
Yeah, this play, actually we were supposed to, as per the contract, we were supposed to do the ground improvement for 5 ton per square meter, sir. But the soil over here is completely sand. So even the filling has been done with the sand. So it didn't require any ground improvement technique for this, sir. Otherwise, generally what ground improvement techniques for such vast land development that we use is either by sand pile method or with the other.
Columns.
Yes, sir.
Thank you, sir.
Yes. Depth of the pile is around 54 meters, sir.
But is it okay for the single wall mooring system where basically the ships come, that is the ships?
Yeah, it is for the ships. It is basically for oil ships, sir. It is not for single mooring system. It is for oil to berth at the bridge. It is a single mooring system is about about 20 to 30 kilometers inside the sea you provide, but it is not a single mooring system.
What is the diameter of the 4,000 tons pipe?
It ranges from 1500 dia, sir. 1500 dia to 2500 dia. What we did was 1800 dia pile.
1,600.
1800, sir. 1800 dia pile.
Sir, after completing of piling works, you told that pile load test will be conducted.
Yes, sir.
Is there any integrity test means what is the integrity of the piles?
Yeah, we do pile integrity test on all the piles, sir.
Okay.
Yeah.
Because of the sea, I believe some sulfate and chloride attacks will be there more on the concrete.
Yes, sir.
Are you suggesting any microsilica or GBFS, something
No.
like that, or only you are taking only plain cement?
We are going with, see, the OPC cement generally attacks with the chlorides, but the PPC cement or the slag cement doesn't attack with the chlorides. So we are using the slag cement for this.
Thank you, sir.
Yes, sir.
What is the average cost of the pile load test we had here? Pile load test.
Sir, it depends, sir. It costs up to even 1.5 crores. The maximum what we claimed is around 1.5 crores because the load test that we conduct on land costs less. If you are conducting on a sea, you have to have a platform and all other things. So it costs higher. It goes up to 1.5 crores if you have to do it in a C condition.
During the bentonite solution, when you are, I think, complete it end to end, how you will confirm that bentonite solution is any test you?
Yeah, we test the density of the bentonite solution, sir. It should always maintain between 1 to 1.05. The solution has to be maintained. When we just pump it out from the pipe, as far as land is there, you mix up a fresh bentonite, it always gives you 1.05 or so. The same density has to be there when we flush it out, and at the end when we see, the same density is to be there.
Okay.
We check the density of that.
How do you ensure that the bentonite that is not contaminated in the mix? How do you ensure that?
Yeah, you see, this is what I was saying. No, the bentonite solution is in the pile. Once we complete the complete pile, the solution in the pile is seen that it has the density of 1.05 only. Now once the concrete goes down, the concrete pushes the bentonite up completely, and at the top we generally overflow 1 meter higher than the cutoff level that is required. So that 1 meter is chipped up. That is how the bentonite and this one does not contaminate.
What was the contract that you
217 crores, sir.
what are the incidents you have taken?
I am not able to hear, sir.
Hello.
Yes, sir.
What are the insurances you have taken there?
We have taken the car policy, sir.
Okay.
Yes, sir. But if you are an insurance man, I am sorry to tell you, if you are an insurance agent or an insurance company, if you are coming over.
No, I'm not from the company. I'm an insurance surveyor.
Yeah, if you are an insurance surveyor, we are very sorry to tell you, out of my 37 years of experience.
Yes, yes.
You tell something before you collect premium, and you do something after an accident
I'm
occurs.
not from the company, sir.
Yeah,
I'm an insurance surveyor.
that's what I am saying. See, the surveyor is the person who pays the amount,
No, no, no.
and he is the middleman between the insurance company and us.
Yes, yes.
Yeah, so generally surveyors, whatever I have seen, that's why I said I am sorry. I don't know about your this thing, but with my 37 years of experience,
Okay.
no insurance surveyor gives us a bold statement that yes, this is an accident, because marine works or any technical works, the surveyor is not a technical person. The insurance man who sits at the head office is not a technical person.
I just want to correct, sir.
Yeah.
Insurance surveyor is a technical person. He will be a mechanical engineer, he will be a marine engineer, and he will be an electrical engineer.
But insurance company is very smart
Company is
enough.
different. Company
I'm
is
telling you,
different.
insurance company is very smart enough not to detail a technical person to a technical work.
No, no, sir. I mean,
Yes,
there
sir.
are a lot of things.
Sir, I'll show you all my accidents, whatever 3-4 accidents, whatever has happened, I'll show you. None of the places we have been fighting with them. These insurance surveyors, of course, not the insurance companies, the agent who comes over here, he tries to take the premium, he tries to take his commission out, get out, and then the fight between us and you takes place.
No, one thing I can assure you,
Sir.
if you have any damage anywhere, you call me and I will satisfy you fully.
Yeah.
Okay, sir.
Okay. Thank you, sir. Thank you. That's why I said sorry in the beginning itself. Yeah, if time is there, I'll give otherwise. Yeah. Next. Yeah. This is one of the, this project we have done in the year 2012-13. Just hold on. This project is a project which we have done for SR when even Ms. Suryanarayan Garu was there at the time. I think he just retired at the time. This project we have done it in the sea for about 12 kilometers from the land. So logistics, planning of logistics and all these things, high tide, low tide, in this project is done in Gujarat, and you know the high tide, low tide, there is a variation of 6 to 8 meters in the high tide and low tide. So the logistic planning is also very important over there, because you travel in the high tide and low tide times keeps changing. Generally, if you want to go for a work at 8 o'clock, you find a low tide and your boat will not go. So there are a lot of problems we faced over this, but by God's grace and with the help of SR, we could complete this job on time. We not only doing this job on time, and seeing the success of completion of this job, they have given us 3 more jobs, which I will just show you how technically we have done, and we have put in all our efforts for that. So just a gist of the project. I don't want to waste much of the time on this, because all works and all you have seen earlier. Just a small video only. I will just show you over here how it has been done. This is a coal jetty for SR at Salaya in Gujarat. So this is the project which we have done in the sea, about 12 kilometers away. So everything, manpower, water, everything has to be transported over boats only. So this is how the jetty is being constructed with the help of barges and all. Of course, we erected the gantries also with the gantry piles were going on over here. From back side, you can see the works also being completed. For completion of the work, we had erected additional gantries from the other side also. And this is the electrical substation and control room. This is the approach. These are the precast items and other things. This is about 45-ton block which is being lifted and put over the piles. This is a precast block which has been done and then put over the piles. See the accuracy of the work being done. You have to praise all the engineers. This is on 2 piles. See, if it is a one hole, you can just take it and put it over here, but this is on a 2 holes, 2 piles. It has to be so accurately adjusted. And in piles, generally you can't take the pile exactly at the location whatever is there. There is a sway also. Maybe it is allowed even as per IS also. About one time the dia are 1 in 10 of the pile, but still our engineers have taken a great care to see that this is lowered exactly at the locations. Next. Hold on, just hold on. Now this jetty has been completed. The approach, whatever you have seen, approach has not been done because there is no environmental clearance or some obstruction was there for them. Jetty is done up. They already spent around 110 crores over that. Now what to do? Sir, at that time, when Reliance or whatever is there, they don't want to waste their money just like that. Then they how do we move ahead? Because a crane of around 500 tons has to be installed on this jetty. So they thought they will finish off the approach. Through approach they can take the crane and put it over here. So that didn't happen. So their project manager, one Mr. Joshi was there, and we were there. We were given the task to take a 500-ton crane and then put it over the jetty. So that video I will just show you. Yeah. How we planned this, how to take the 500-ton crane over the waters, put it over there, take it there, erect it, and then give it to them. It has been planned and we successfully completed within 3 months. The proper suitable barge has been selected for this. A frame has been made. This is the frame which has been made over there. For the height difference for the crane to roll onto the barge, it has been placed on the barge. Once it is placed on the bus, the crane, which has been dismantled into parts, has been erected on that one. Like first the crane track has been dismantled, tracks have been put up, then the crown has been put up over that. We didn't have so much of technology at that time to take the video, continuous videos and all. So whatever the photographs we had, we made a total video. After that crane is put over here, we took the tug and this has been taken over to the location. I will also show you in one of my next slides how difficult it was to tow this 12 kilometers from this location. All the way it has to travel all this. If you see, there is only a small channel over here. It has to be taken only in this channel. And it just took 8 hours 30 minutes for us to travel from here to this place. And it started at around night 1:30 and reached there in the morning by around 8:30. Because the tidal variation was taken up. Whenever the high tide was there, it was taken to be traveled to that location. And after it has reached the location, how we launched, and that is the reason why we made this platform higher, to take advantage of the high tide and low tide. The jetty and this has been joined over here. We are very successful over here. Now the crane has to be moved very fast because the recedence of high tide is also very fast over here. It is not that it goes there high tide and the high tide stands over there. So for that, what we have planned is in the barge itself we have put a compartments wherein the water has been filled up, and then that how much depth it is going down and up, it has been calculated, and it has been dewatered, and as well as water has been put into that, so that the level at which it is being transferred from the barge to the jetty has been maintained to an mm accuracy. So you can see, imagine the crane, and the travel speed is very, very less. No, it has been taken from the crane booms. This is how it was stated, and this is the most critical activity for us. Critical time wherein everybody is in tension because the level has to be maintained exactly at the same. The weight of the crane also comes out. That also, so many calculations. Of course, all engineers must be proud of yourself for having done such a great job. See the pumping of water being done as per the calculations, whatever is there. 4 pumps have been provided on 4 directions.
In the present days, you can use drones, sir. In the present days, you can use drone cameras. Present days. You can use drone camera.
Present means you would have taken all. This is all taken from a boom of cranes and all other things, whatever is there. So this is how it was taken up, and after doing this, after the crane was erected, everything was there. Then the ship which was supposed to come over to this, the ship captain said, no, we are not going to bring unless we have a safety system over here. So again, seawater intake has to be done over here. So that is again another biggest task that was given to us, and they just give us 3 months time again. You have got to complete this within 3 months time. I said, I wondered, seawater doing at 12 kilometers, 3 months time is impossible. But still, with the help of, with the support of Mr. Joshi, who was sitting over there, we all sat day and night for about 10 days. We worked out the system, and the system has been brought out and successfully. Maybe it might take another 10 minutes for me to give a presentation of that. So we will go for that. Next. Yeah, next. Yeah, this is a well which you have got to construct, 22 meters dia and about 17 meters depth into the water has to be done, and this shell has to be transported right from same place, 12 kilometers it has to be transported. It's the Chisel technique what we utilized over here, and how we utilized over here is just explained in the next slides. So all this explanation and all, I'll just leave it and move forward. The tonnage what it took, how many days has been planned, also has been put over here, 45 days for manufacturing the bottom shell. Then the timelines are put up over here. Next. This is a shell what we have put out like any well. Most of you must have seen a well sinking wherein you provide a cutting edge for at the bottom. The cutting edge has been made over here. Next. The shell has been calculated to see that even if it is left in water, it just floats. So about 4.5 meter shell has to be prepared with a 1.5 meters width of this. Complete waterproof has been built up, and then after even doing that, just simply putting the shell won't work it out. So to lower the center of gravity and all, we have laid a concrete of around 30 tons at the bottom, and then taken it up onto the barges and then put up. Next shell. Next. This is how the outer and inner are calculated, are fabricated. Next. Next. After fabrication of this is over, this is lifted with the help of a crane of about 250 tons with a radius of 38 meters. So it has been just lifted up and put up on the barge. Next. These are the two barges which have been joined together. One barge is this, one barge is this. These are tied up with tie beams, and then in between the center we had lowered the well. Next. This is how in AutoCAD we had made all the drawings made ready so that you don't make any mistake of any of those issues. Next. Next. This is how this one has been lowered onto this in between the barge, whatever I have shown you the gaps. Next. Next. Yeah, after this has been set up over here. Then it has been totally laced so that it doesn't move this side nor that side. And then as per the calculation, whatever is there, it has been planned out. Next. After this, we have to build up some more height of the shell, because as it keeps traveling, we thought some more height is required, so we fabricated it over here, because more than 75 tons we don't have a crane capacity to lift it at a radius of 38 meters. So the additional weight of another up to 12.5 meters we have manufactured the outer shell and inner shell at this location only. Next. This is how the shells have been put up. 12.5 meters is the last stage that we have done. The complete welding, everything has been done, including the supports and all. Next. Now again the same route you can see over here. The earlier one we are taking it in a barge wherein we require a draft of only just 1 meter, but whereas this requires a draft of around 4.5 meters. So we were facing a lot of difficulties, so we were just waiting for the highest height to happen. All the calculations were done, how to travel over here. Even the bathymetric survey of the complete 12 kilometers area has been done, routing how it has to be done. And then we had placed on buoys for showing the direction of travel and all, because it has to just travel in that high tide time of 3 hours or 4 hours. These are the high tide calculations that what we have done, how much time it is going to stay during the high tide, and what is the time that we have, the travel time required for us has been calculated. Next. So the sequence of operations for shifting has been done in 5 stages. Whatever is there, we will keep showing in this. The explanation of each stage has been done. Next. Next. Yeah. This is the towing plan that has been done on the AutoCAD, showing these things. We had explained to them. There are two tugs which have been deployed for this, with an additional tug also on spare on this side and spare on this side, because if anything happens in between, suddenly immediately it has to be taken out and then moved out, otherwise the whole thing gets spoiled up. So this is the plan, and this is the elevation, how it is being moved. Next. So you can see the whole system over here. Next. This is how it is being traveled from in that location. Next. This is in the night time. As I said, the same time we got it around night 12:30. We were supposed to start and reach out to that location by around in the morning 6:30 or 7. So this is how it has been traveled. Yeah, once it has reached to the location, then the seawater pipeline requires some of the outlet pipes and other things. So they have been constructed at that location, and then they have been put over here. Next. Next. So the total depth is over here. Now after taking this into the location, next slide. These are the stages, how it has been done, because once it goes into that location, that area has to be dredged and it has to be made in a level so that the well doesn't tilt or shift. So accordingly, the whole of the bottom has been dredged over to the depth whatever is required, and the bits whatever is required. The bottom has been leveled up with metal, and then it has been kept ready. Next. Next. Yeah. Once the whole of the system is over, it has been put at this place, and you find the concrete being filled up with these 2 cranes around the system equally, with in 4 sides filling it up equally so that it doesn't tilt or shift. You can find a little bit of shift over here, but it has been corrected by putting over concrete on the other side, and it has been leveled up. Slowly it has been seen that it went up to the bottom. Next. Then the additional cells are added up to our 17 meters depth, whatever is required. Once it goes down, the additional cells were kept on adding up, and then again the concrete was started filling it up. Next. 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 Yeah. This is the high tide time, and at this place our work has been completed, well has been grounded well, and then this is the high tide time. Just go to the previous slide. This is during the low tide time. Well, you suppose the height of this is around this much during low tide, and during high tide is the next slide. Then once this is over, the pump house has to be constructed over this. So the frame, it has been done with a steel structure. Frames have been done. Next. The frames have been done. Next. You can see the frames that have been done with the steel structure, and over this is a natural one, like structure developed with the structural items only, and then the pumps were erected accordingly. So from here the water has been pumped out. Again, after this well has been done, this from here we have to make an approach to the jetty. So the jetty has been constructed after this. Next. So from here you can see the jetty being connected from here to the location of our jetty, connecting our existing jetty. Next. This is how it was there. Next. Next. Yeah, this is how once the well is over, how the concreting has been done, and how underwater drivers have been done. This system, we had made the system before completion of this itself with all these things. We had explained to all the engineers that this is the system what we have to follow. Then only the work has started. So it was explained very well to all the people who are there. And the work has been successfully executed. Of course, not in 3 months, we took 5 months to do the job, because we had a lot of problems. After going to that location, we found that there is a rock at the bottom, and then we have to chip that rock and make it to level, otherwise the well is going to tilt. So that has taken more time for us. We didn't expect that much of trouble we get it, but it took a time for us, especially in one of this corner like this, rock was there. So we have to chip that and then place it over here. And of course we shifted the well by about 3 or 4 meters away, but the jetty was connected to that, so that there was no problem. Next. Yes, these are the pump house structures and all which is being done. Yes, sir. These are the things. So any questions on this? Salaya oil moorings are not there, sir. In Salaya, it is behind. It is, I think, it is in Vadinar. That's why I am saying Salaya. It is not the Salaya. Yeah, it must be. I think more than 2 to 3. More than 15 kilometers. I think from this. Yeah, because from the Vadinar, this is 12 kilometers to the left side. Your SPMs are to the right side, which is about 3 kilometers inside. Yeah, it was not there. So any questions? Total cost was around 150 crores, sir. Initially it was jetty only was done for about 100 crores. Later on these two, we had another 50 crores. Yeah. So thank you very much, sir, Professor P.S. Rao garu. I think I have given whatever best I can do. So any suggestions, anything, I would like to take it up from you, sir. Which one, sir? Design safety factor for all the temporary works we have taken only one, sir. Permanent works as per design. Yeah, we are not gone more than one, because if you are going as per the design, the cost is becoming very high. So we all thought, sat down and then thought it is not that much is not required. So we took it only one, or even less than one also. I think we took it up.
Professor P.S. Rao garu, please come on to the dais and give your comments.
I have a few questions to him.
Sir.
As a professor in engineering college.
Sir.
First of all, congratulations, you have made a very good presentation.
Thank you, sir.
It's a real engineering job which you are doing, and people have come to know what sort of difficulties you face when you execute such mammoth projects.
Sir.
I have seen while erecting that, I say about 30 to 40 engineers, workmen on the deck. What are the qualifications of these people, of these 50, 60 people? You require mechanical engineers or civil engineers or workmen? What is the
No, we had taken up civil engineers, mechanical engineers, marine engineers, sir. All the three were involved in this. Marine engineers are used for that high tide, low tide calculations, barge calculations, draft calculations, how much it is required. We had employed the marine engineers. And civil engineers, of course, the design of structures and all was done by them. Mechanical engineers, the structures was done.
And require skilled workmen also.
They are all skilled, sir.
Skilled workmen.
Yes,
now, my question is, all of them must be having experience.
Sir, none of us have got any experience on this, sir, before we did the job. After the job only we got the experience.
So you learned on the job?
Yes, sir. We learned from the job only. We sat together because nowhere it has been done at that time. I don't think anybody has done such type of jobs by that time. But we took ourselves, we had sat there for 10 to 15 days without moving out from there. We had put on all our plans. One is from SR side we have taken up. The SR has got a consultant also. So from their side and from our side. The three plans, they have given us 4 days time initially to bring out individual plans. Then we sat together, we came to a conclusion that this is the system what we follow, and then we went out accordingly.
So how do fresh engineers, how do fresh engineers find themselves in your organization?
From our side we have got around 6 engineers at that time, sir.
No, suppose you recruit some people, fresher,
yes, sir.
He doesn't have any experience.
Yes, sir.
So do you have any methodology for training such people? Letting them or?
Yeah, nowadays, sir, it is not the days like you. We take the engineers. So we generally take around at least 10 to 12 engineers every year, sir. But ultimately at the end we find only 2 or 3 remaining with us. At the end of 6 months, they start rotating out and then move
Such
out.
a challenging job.
Yeah.
And real engineering job. Whereas a counterpart of his sits in an air-conditioned room in a computer.
Yes, sir.
And he makes maybe as much money or even more money.
Yes, sir.
So we are not able to get good civil engineering students.
See, I just want to give an advice to the younger engineers. The kind of satisfaction that you get once you complete such type of projects, nothing can give you. Not even any amount of money that you earn or any amount of face value that you have, whatever is there, you will not get the satisfaction what you get in such type of project. All marine projects are typical. It is not similar. Each project is typical and each project has got its own problems. So, why I was telling you in the beginning, why he lived for 100 years and how you can see how active or in our presence you can see Professor P.S. Rao how active you are. Because every project you change your methodology, change your system, your brain becomes fresh. It is not a monotonous job like in IT or whatever it is not a monotonous job of just putting A plus B is equal to C. Here it is never in any of these projects A plus B will never be equal to C. Each project changes its system. So your mind again starts with a fresh project after 3 years, it again starts fresh. So that is over, you again go to the next project. You still feel fresh again. So your energy levels keeps increasing. So at least the core engineers, my advice is please stay back. As I said, please have what is your need? First of all, you understand your need. What is your need? You want to earn money, you want to earn as a professional in engineering, whatever it is, you want to become IT, whatever it is, you select the subject first itself. You have your commitment, whatever is there. then see that it is implemented. And this happens only in civil engineering. It cannot happen in any other engineering or any other subjects. It cannot happen. It can happen only in the civil engineering.
Is
But
there any third-party inspection for such jobs? What you are doing?
the, third-party inspections are there, sir. Definitely they are there. They are done it with the IRS or Lloyds.
Can you name any party?
IRS is there, sir, and Lloyds also is there, sir. Lloyds mostly come for such type of inspections, sir. IRS generally comes for barges and ships.
Sir, what you are expecting from young engineers? Basically, why young people are coming and two people are only staying? Here, academicians are here. Most
Yeah.
of them.
Yeah.
You are from industry.
Sir.
Students are there.
Sir.
We want to coordinate where some missing is there.
That missing is only the patience, sir. You must have patience while you get into a job. That's what I am said. First of all, you decide your need. Whatever is there, you decide your need. You want to become IIT professional, you want to become a core engineer, you decide yourself first. My advice is, please stay in your core engineering. Don't go for IT or any other thing. The moment you finish up, you can see our Mr. Suryanarayan Garu or Venu, whatever is, they are doing beautiful jobs over here. It is not that they are doing for themselves, they are praised by many of the people outside. If you are staying in your core subject and you have a satisfaction in achieving in your core subject, if you are in IT or electronics or whatever it is just a similar project. Here the project keeps on changing every 2 years. So my advice for any one of you is that you select yourself. If you are in a core engineering, be in the core subject, that's all. The money will automatically come. Do not run after the money. The money will automatically, the moment you have the knowledge, it will automatically come up. You know, I'll tell you my own personal story. About 2 years back, we had lot of problems. The company has had lot of problems wherein it was supposed to die down. Then the chairman, I met the chairman of the Bank of Baroda and then said, sir, even if I asked him, we wanted these are the facilities that I wanted for the company to really to come back into the position. Then he said, if it droops down, what are you going to do? I said only one thing, sir, even if you put me on the road, I have knowledge, and 5 years down the line, I will come to this stage again. There is no problem in that. And mind you, with that, he has sanctioned the loan immediately and the company is revived. So you have the knowledge, nothing can beat you, I am telling you. You have the knowledge comes only through hard work, no shortcuts for gaining the knowledge. You have to have the knowledge, you have to have the spirituality in your mind. Spirituality, I doesn't say the spirituality and God are not the same. Spirituality is completely different. Spirituality is what you are, who you are. Learn for yourself who you are and spend at least 1.5 hours to 2 hours in the morning for your own self. And if you do this, nothing can beat you in this world, I can tell you. Just spend at least 1 to 1.5 hours for your own self. It is a must. You are spending 22 hours for all others, and if you can't spend 2 hours for your own self, there is no use staying in this world itself. There is no use. So please, my advice is spend some time for your own self, either doing meditation, yoga, walking, whatever it is, whatever style you want, you have to be within yourself. Don't bother about anything. Today, suppose, even if I am not there today, do you think the world is going to stop? It is not going to stop. Even if you are not there, world is not going to stop, it is going to run. So forget about what is going to happen in the future, or forget whatever has happened in the past. Live in the present moment, be happy, whatever is there. Whatever problem you have, it will get out, I am telling you. You yourself will think of what is, you are in the first year of engineering. What is your status of mind? If you have a problem, what is your status of mind? How did the problem got out of its way? It is not going to stay with you. The problem will never going to stay with you, I am telling you. It will automatically die down. So please remember that, stay in the present moment, do things happily, and whatever you do it happily with a laughing face. You will be a successful leader or successful entrepreneur in any one of the things. Thank you so much for giving me the time.
Thank you, sir. Thank you very much.